All right. Today we are doing Riemann sums with tables. I guarantee that what we learned today is going to be a free response question on the AP exam in May. If there's one question I know is going to be on there, it's this one. It'll absolutely be on it, just like the way we're going to look at it today. This is a question that either you will get full points or not any points. Okay, and I hope that most of you, like 99% of us, will get full points on this. Okay, this is the thing that you need to do well on because it's some easy points on the AP exam. Okay, and it's just a matter of doing what I tell you to do, and you'll be fine. Okay, based off this following graph, we're going to use the area of the rectangles to approximate the area under the curve. So we did this right before we started reviewing. So looking at this first rectangle, this blue guy right here, we're finding area of a rectangle. So Luke, what's the width going to be? 10. What's the height going to be? Also 10. So it's 10 times 10. This guy's 100. Okay, we're going to find the area under the curve. So let's do the next one. Okay, if I'm looking at this next one, Emma, what's the width of the next one going to be? 10. Because it says 20, but I started at 10 to 20. So it's 10 across. What's the height going to be? It's going to be 30 because it's the y value, right? And so we're going all the way up to 30 because it's 10 across, then we're 1, 2, 3 up. We're 10 times 30. Okay, we're going to add these things together, so that guy's 300. Okay, my next one. Alana, what's the width of that last one going to be? 10, because I'm going from 20 to 30, so the span is 10. What's the height going to be? The y value, it's 25. So this is 250. If this were the AP exam, you put a box around that, and that's your answer. Okay, the easier way of writing it, since they all have a 10 in it, you could do this. It's like I just factored out a 10 out of each of them. That works as well. Okay, I would just do the green one, but you can do that one as well. This one might be easier for you. That works as well. You could get the actual answer and do 100 plus 300 plus 250, but you would have to write it out first. Okay, and you would have to write the answer. The correct answer is 650, but this is what you need, or that is what you need. That is how we find the area under the curve. We approximated using rectangles, because I don't know what the shape of this weird guy is, but using rectangles helps me to approximate. Questions on how we set that thing up? All right, so today we are estimating amounts with RAM. Okay, remember what RAM stands for. RAM stands for the rectangular approximation method. That's what it means. So we're making rectangles here. Okay, this is a weird concept, and it might look strange at first, but once we do it a few times, it becomes really easy. All right, so you're reading from a car speedometer at 10-minute intervals during a 1-hour period. So you're driving your car. At 0 minutes, you look down, your car is going 26 miles per hour. Okay, at 10 minutes, you look down, you're going 40 miles per hour. At 30, you're going 10 miles per hour. At 40, you're going 60. 50, you're going 32. 60, you're going 45, and so on. Everybody understand what's happening? So I put those dots on this paper over here. I don't know what the other things are doing. All I know are the dots. Okay, I can make believe what the line looks like. Maybe it looked like this. And then it zoomed. Zoom. Zoom. Scoop. And I did that. I don't know, but I really don't care. Okay, this is definitely an approximation is what we're doing. Remember, that's what the A stands for in this. Okay, the rectangular approximation method. It's an approximate answer. So what we're going to do is we're using this to approximate with 3 subintervals the distance traveled during that 1-hour period. Okay, one thing we have to pay attention to. This does not happen often, but I've seen it happen once in about 10 years of calculus exams. Notice that this is in minutes and this is in miles per hour. The units don't match. We want the units to match. We'll adjust. Okay, so we want to go into 3 sub-intervals. I'm going 60 minutes, 3 sub-intervals. How wide does each interval need to be? 20 minutes. Everybody agree with us on that? 20 minutes apart. So you need to do exactly this on your paper, okay? Because if you don't do it this way, you'll screw it up. Put a dot at the starting spot, so 60, or at 0 right here. Notice that I'm putting a dot right in the middle of the 0. And I'm going to go 20 minutes. So I'm going to go up and over to 20, and I'm going to connect it with that line right there. If you do that, this is really easy. So I connected those 2 things with a line, up and above, just exactly like that. Okay, then my next one. When is my next 20-minute interval going to go from? from 20. So put a dot on the 20 and go up and over to the 40. There's my second interval. And then I'm going to have one more interval from when to when is my last interval. From 40. So we're using 40 again, and we're going to 60. That is the 3 sub-intervals. Everybody understand what's happening so far? So again, here's what we did. We split this thing up. We went from 0 to 20. We went from 20 to 40. And we went from 40 to 60. We basically drew these 3 lines so far. It's minutes. So yes, it is 20 minutes, but we want to convert to hours. So that first subinterval, how many hours is that thing? It is 1/3 of an hour. 99% of the time, we would just say it's 20 minutes. Okay, but it's a weird one because it goes from hours to miles. So we're going to say it's 1/3 of an hour. What is the height of my first rectangle going to be if we're going to approximate using LRAM? What does that L stand for? Left. So this is my interval. This guy right here. I want to use the left number. So what is the left number going to be? The height of 26. So it's like us doing this. We're going to go from 1/3 times 26. It is this part on the graph. That's what we're doing. Boom, boom. It's 1/3 of an hour, and I use the left number right there. It's 26. There's my first one. I'm going to add to that. You have to put a plus sign. You don't, you're going to make a mistake. Will, how wide is the second interval going to be? 1/3 of an hour. Absolutely. It is 1/3 of an hour again, or 20 minutes, but we want to go an hour. So it's 1/3 times the height. I'm going to use the left Riemann sum. So Talon, which number am I going to use? 55. The one, look, I drew this little rectangle box guy. It's the number on the left side. It's at 55. Okay. So we're using this 55 right here, and we're drawing a line across. I'm attaching it on the left-hand side. There's my second one. I'm finding the area of that guy right there. To find that area, I would take 1/5 times the height of 55. Then I've got my last one. Macy, what's the width of my last interval going to be? 1/3, 20 minutes, or 1/3 of an hour. Macy, what's the height of my third triangle going to be? Or rectangle, yeah, 60. It's the number on the left-hand side. When I connected it, it's the one on the left-hand side. So we're picking the 60, which is the height here. Here's 60 right there, and we're going to draw a line across. This is the area. I don't normally need this graph. This graph isn't going to be actually used very often, but I got it there. It's 1/3 times 60 because that's the height. That is the answer to my question. If this were the AP exam, I would put a box around this answer and I'd call it a day. All right. If you wanted to, since all of them have a 1/3, you could factor a 1/3 out and do it this way. That works as well. I would tell you pretty much never to get an actual answer unless you had your calculator. Let's say we had our calculator and we added all these things up and then multiplied it by 1/3. My answer is 47. That is the answer to this approximation. Now the question is, what are the units going to be? What was this 1/3 units? What is that? Well, the 1/3 is going to be in what? That is hours. And I'm multiplying it by the 26. What is that 26 measured in? Miles per hour, right? What happens if I take hours times miles per hour? It is hours cancel, and all I'm left with is miles. That's what we just did. We looked at our speedometer a couple times during this time interval. We drew some area. We found the area under the curve, and when we did that, we went from miles per hour, and we went to miles. Okay? That is key in what we're doing. Let's look at that real quick. What we just did was we approximated an integral. We didn't actually use an integral, but we approximated an integral. It's the opposite of a derivative. Okay? What an integral is, it's going to be the change in, and then blank, whatever is one level above what you integrated. Okay? So when I say that, we just integrated velocity. What's going to come one level above velocity? Distance, position. It was a rate. It was in miles per hour. Now it's not going to be a rate anymore. Now it's going to be an amount. Now it's just miles. So it's the change in miles is 47 from 0 to 1 hour. That is what we just found. By finding the area under the curve, we found the change in miles. It is 47 from 0 to 1 hour. It's weird. You do a few more and it'll make more sense. Questions so far?
So when we answer this, or we have to write?
If it asks you to interpret, it'll be very clear. It'll say interpret what you just found. All right, here we go. Number 2, it says Kathleen skates on a straight track. She starts from rest at the starting line at 0, and then from 0 to 12, she is skating. In feet per second, it's differentiable, and then underline or highlight that increasing. And we'll come back to that. So they gave me time. They gave me a rate, feet per second. We're going to use a Wright-Riemann sum. A Wright-Riemann sum with 4 subintervals indicated in the data to approximate this guy right here. Okay, so that's what we're doing. We are approximating that integral. This is an integral from 0 to 12, k of t dt. We're going to approximate it. We're finding the area under the curve using L or R ram here, a Wright-Riemann sum. We're doing 4 subintervals. How many numbers did they give me? 5, which is exactly what you want. If you're doing 4 subintervals, you need 5 numbers. If you want to do 5 subintervals, you need 6 numbers. Because look, let's draw the little connecting caps. So we're going to go from 0 to 3. There's 1. From 3 to 5, there's 2. From 5 to 8, there's 3. And from 8 to 12, there is 4. Oh yeah, I needed 5 numbers to make 4 intervals. Are all of those intervals the same distance? No, but they don't have to be. Since they gave me that, I'm going to have to live with it, and I'm going to use whatever they gave me here. All right, let's look at that. Okay, so, Jonah, what's the width? How much time is on the first interval?
3 seconds.
3 seconds, because we're going from 0 to 3. And then we're going to multiply that by the height. We're doing a Wright-Riemann sum, Jonah. So what y value are we going to use for our height? 5. The number on the right. We're going from 0 to 3, and the height is going to be 5. So 3 times 5 is going to be my first one. Then I'm going to do my second one. Isabella, what's the width of my second one going to be? 2, because she's going from 3 to 5. So her width is 2. What is the height going to be if we're doing a Wright-Riemann sum? That is 10. We're picking the number on the right, so it's 2 times 10. Omalati, what about the width of my next one? It's 3, because we're going from 5 to 8. What is your height going to be? 20. Pick the number on the right. And then my last one, Max H, what's my width of the last one going to be? 4. What's my height going to be? 24, the number on the right side. So it's 4 times 24. Boom, there's my answer. I could just leave it totally like that, put a box around this guy, and call it a day. Okay, unless you have your calculator, leave it like that. We could do that. If I were to type that all into my calculator, you would get an answer of 191. What would my units be on that guy? It is going to be feet, because we had feet per second, and then we multiplied by seconds. The seconds would cancel its feet. You had a rate of something. You had a rate, feet per second, and then you integrated it, so we found the amount. So it's the amount of feet traveled. So from 0 to 12 seconds, this person traveled 191 feet. That's what that means. Questions to that point? Part 2 says, is this an over or under approximation? And we started talking about this the other day. To do this, to decide if it's an over or under approximation, you need to understand the picture. So I'm going to draw an increasing graph, draw an increasing graph. You can draw the increasing graph however you want. Okay, as long as it's increasing the whole time, it doesn't matter. I drew an increasing graph. Okay, I'm going to draw a decreasing graph. So just something that's going down. We're going to draw these graphs using LRAM and RRAM. LRAM and RRAM. And understand what the picture is going to look like. And I know this is a little bit weird, but let's look at this first graph. So it's increasing, and I want to think, what would it look like if I did LRAM? So I'm going to draw a little rectangle. Where is the rectangle going to connect? On the left side or the right side? The left side. So pick a dot on that graph. That's going to be the left side of a rectangle, and I'm going to draw a rectangle from there. Okay, and then I'm going to pick right above. Oh, I need to go up to there. The left side and over. I'm going to go, oh, right there. Left side and over. I don't care how wide the rectangles are, but there's my picture. If I do an LRAM graph and it's increasing, are these rectangles an over or an under approximation of the actual answer? Under. This is an under approximation, and it's just a matter of understanding the picture. I hate wherever I wrote that. This is under. Let's do RRAM. So RRAM means I'm connecting from the right. So if I connect from the right, I still hate where I put that, sorry. If I connect it from the right, that means I'm going to start on the right, and that's going to be the right side. So then I'm going to go over from there. There's one. And then I need to go over so that the right side is touching the graph. And I need to go over so that the right side is touching the graph. If I use RRAM on an increasing graph, is it under or over? It's over again. So they're different. One is under, one is over. Let's talk about a decreasing graph. We're connecting from the left-hand side. So I'm going to start on the left, and I'm going to go over. Start on the left, go over. Start on the left, go over. LRAM, decreasing. Is it over or under approximation? Over, because look, I got these little extra areas that I'm using here. And then obviously if I do RRAM and I connect on the right side of this decreasing graph, I am under. So going back to this question right here. My function is increasing. Look at all these numbers. It goes from 0 to 5 to 10 to 20 to 24. Oh yeah, it's increasing. And I used right RAM. Thumbs up if this is going to be an over approximation. Thumbs down if it's going to be an under approximation. I'm increasing. And I used RRAM. Is it over or under? Over. It's this guy right here. It's increasing. We used right RAM. It's over. So right here we're going to say it's an over approximation. And then my justification just needs to be over approximation because we used RRAM and K of T was increasing. That is my justification. You don't need to memorize that. You just need to remember, oh yeah, if I'm doing RAM, I got to think increasing, decreasing, and then draw a quick picture and see what happens. Questions there? We'll do a lot of those as we move on. I know that first glance that looks tough. Let's go to the backside. On the backside, hot water is dripping through a coffee maker, filling a large pot of coffee. The rate of coffee in ounces per minute is given by C of T. Use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate 0 to 6 C of T and then interpret the interval. Okay, so 0 to 6 C of T dt, we're approximating that. How many subintervals are we using? 3. We're going from 0 to 6. How wide does each subinterval need to be if I'm splitting that up evenly? 2. Draw the little caps on top of it that spread each interval out 2. So my first interval is 2 wide. Which number are we going to pick out of those numbers in that interval if I'm doing a midpoint Riemann sum? the middle one. 5.3. That's the middle height. Get an answer. Use your calculator and get a total sum. Go. Renee, what's my second interval going to be here? What's the width? 2. And then my height? Good. 11.2. That's the middle number. And then I'm doing my last one. Madison, what's the width of my last one going to be? 2. What's the height going to be? 13.8. This is my answer. If it were a normal problem, I would just leave it like that. But we're going to go ahead and use our calculator. What did we end up getting there when we added it together? Yep, 60.6. What would my units be? It is ounces because we had a rate. It was ounces per minute. And then we integrated it. So it went from a rate to an amount. Now it is just ounces, 60.6 ounces. So if I interpret it, the change in ounces of coffee is 60.6 from 0 to 6 minutes. That is the interpretation. It was the change in whatever we changed. Oh, now it's ounces of coffee because it's one above whatever they gave me. It was just ounces now, or it was ounces per minute. Now it's ounces. I said the amount. And then the other thing that we need to state there is the time interval. It is starting at 0 and going to 6. Questions with Riemann sums. You need practice at them, but once you get them, you will be excellent at them. Just figure it out. Okay, keep working at it till we get it. All right, the last part here is easy. When I find the area under the curve of a rate, it tells me the amount. If you find the area under the curve of a rate, it tells you the amount. Okay? Let me rephrase. I'm going to say the change in amount. I apologize there. The change in amount. That's important. Okay, it is the change in amount. And we will do that all second semester. Last thing we're going to do today is use our calculator. Okay, so example 4 says integrate this thing on this interval from 0 to 3. Here's what that means. If we're integrating, we're using this little symbol right here. Again, that's an integral symbol. It means we're finding the area under the curve. It's a fancy way to say find the area under the curve. What two numbers do you think I'm going to use on this integral? 0 and 3. 0 is my starting number. It goes on bottom. 3 is my ending number. It goes on top. And then I'm going to integrate my function. In this case, it's x squared sine x. And then we're always going to put dx at the end. Okay? I'm not going to get into too much about what that dx stands for. It represents the width, and it's infinitely small. It's really strange. We'll talk about it more later on. But that's what I'm typing in. All right, so let's break out our calculators. In my calculator, before we took the derivative, to find the derivative, we hit math 8. What do you think we're going to use in our calculator here if we want to find the integral? Math 9. Math 9, right here, it means the finite integral, and that's what we're trying to do. Bless you. We're going to number 9 for finite integral. It looks like this. We're plugging in 0 down here. Bless you again. There's a 3 on top. Make sure you're in radians. I already am. But 0 to 3, and then I'm typing in x squared sine x. I just type it in just like that. And then in the end, the little D box next to the D, we're putting dx. You type it in, you hit enter. There is my answer. How many decimals should I round to? 3. You think that that's silly that I ask that question all the time, but on our final that we just took, I had a kid round stuff to 1 decimal and a kid rounded to 2 decimals. Guess how many points they got when they rounded it to 1 or 2 decimals? They got 0 points out of 4 different questions that they had to round it correctly. They did it all right, but you rounded wrong. That's exactly what they would do on the AP exam. You would earn no college credit. My answer is 5.777. Okay, round that thing to 3 decimals. Questions on the first one? Let's do the next one. Okay, in a marathon, when the winner crosses the finish line, many runners are still in the course. If the density of runners X miles from the finish line is given by this. So this equation right there is a rate. It tells you runners per mile. How many runners are within 8 miles of the finish line? So we are going to integrate. We want to know how many runners, and they told me a rate of runners per mile. So the way I find out how many runners, we integrate the rate. You take the rate and you integrate it, and that will tell you the amount. Okay? So I'm going to integrate this rate, this r of x dx. From when to when do I want to integrate this thing? 0 to 8, because I want to know within 8 miles. So all I have to do is type that in. Type it in. All we got to do is type it in. So we type into my calculator. We go math 9. We're integrating from 0 to 8. Inside the parentheses, we got to type in that equation. So it's that 20 parentheses 1 minus cosine, and then another parentheses, and then it is 1 plus 0.03 x squared. Double check your equations. I had another student that did everything right, I think, but they must have typed the equation in wrong because all of their answers were incorrect. They had all the setup correct, but by not double checking your equation, now all of a sudden you miss all your points. And that's a lot of points if you don't do it correctly. 166.396. What would my units be on that thing? Runners. That's how many runners are within 8 miles. Oh, it's runners. Should I round it to a whole number? No, you round it to 3 decimals unless she tell you otherwise. I don't care that there's 0.396 of a person out there. It's cool. Leave it. Questions on example 5. Uno más. Look at example 6. Read it with your neighbor. Be careful with your bounds on number 6. So looking at this in example 6, on a certain workday, the rate in tons per hour. Again, they gave us a rate of this gravel arrives by this equation. This is the amount, or I'm sorry, the rate that it arrives. When t is measured an hour from 0 to 24. Find the amount. The amount, we're going from a rate to an amount of gravel that arrives from 3 a.m. to 1 p.m. So to go from a rate to an amount, we integrate. From when until when do you think I should integrate this thing? 3, because that's my starting number, and then I want to go to 1 p.m. Again, notice that I'm from 0 to 24 hours, so my top number should be 13, because that's 13 hours after midnight is when that is. I'm integrating this rate, so I'm just going to integrate. I'm going to just write G of t, because it's a calculator question. All I got to do is integrate that right there. So in my calculator, let's type that in. So in my calculator here, I'm going math 9. I'm integrating from 3 to 13. Then I'm going to type this equation in. So again, this equation looks like this. It goes 90 plus 45 cosine t squared over 18. I hate typing that in. I screw it up all the time. So I go alpha F1, and I'm going to click on the fraction button. Okay? If you type it in as a fraction, you won't screw it up. So where it was a fraction on my paper, I'm just going to leave it as a fraction on here. X squared over 18. I do need to close that parenthesis. You don't have to, I guess, but I do that. Alpha F1 is fraction. It's just helpful. You don't have to. You could have just done division, but I just like to make it clean. And then it's all over, or it's a dx in the end. We typed it in. We hit enter. That is my answer, 890.683. 890.683. What would my units be on that guy? That is in tons. It was tons per hour, but when I integrate, basically you lose the time. That is the change in the amount of gravel during that time period. That's what second semester is all about, is understanding what integrals are. You now know at least a good chunk of it. Okay, we'll keep going from there.